So yeah,
I have 4.5.
that sounds good. So like 9/2, it should work out nicely just the way these problems are designed. So when we write the equation of the tangent line, you need two things. You need the slope, which comes from the derivative, and a point. Right. So we know that x is 2 and y is the square root of 2 squared minus 2 plus 7. So it ends up being 3. So that's your point. Your ordered pair is 2, 3. And then you said the slope was 9/2. So you write y minus y1 equals slope x minus x1. So y minus 3 equals 9/2 x minus 2. Y equals 9/2 x minus 2 plus 3, like that. So that's everything here for that one.
Okay. Okay, I got it in.
So here we want to do the next one. Email. Can't tell I'm stalling because I can't find it. There it is. Okay. So this one doesn't make ton of sense. Like there's a kind of an order we should do these in if you want to better understand it. Problem is the next one that came in isn't really in that order, but
Okay.
you want me to do them in the order they came in?
It doesn't matter if you think one is better than the other to do.
I mean, we'll do this. So f prime of 2 is -4, g prime of 4 is 3/8, g of 4 is 2, y equals f of g of x. What is y prime of x equals 4? So you start with the thing that they're giving you, f of g of x, and this is a pure chain rule problem.
Okay.
Okay, pure chain rule. So what that means is it's like straight from the definition. So if you go to any like reference in the world, it's going to say f prime g of x times g prime of x, like that.
Okay.
And so when you evaluate it at 4, when x is 4, what you're saying is f prime of g of 4, you're putting 4 in for x times g prime of 4. So that's this line down. Yeah, that's what we're doing here, putting 4 in for x. But again, this first line is the pure like derivative rule. I think I sent you that reference sheet for derivatives, maybe not, but it's purely there. Meaning that it's just a straight definition.
Okay.
Here it is, right there. You want. Okay, so we need g of 4. We need g of 4. We need g prime of 4. So g of 4 is 2. Sorry, I couldn't find it. So g of 4 is 2. So it's f prime of 2 times now g prime of 4. G prime of 4 is 3/8. Okay. F prime of 2 is -4. And then you can simplify this. So it's -12/8, divide top and bottom by 4, -3/2, like that.
So you just use the chain rule every time for this?
Well, in this type of problem, yeah, there are a few variations on this, but this is a pure chain rule problem.
Okay.
All right, so the next one I have here in my my thing here is this right here. So this is another chain rule problem,
Okay.
meaning that you have to know the chain rule to do this. And see it like it kind of looks like a power rule problem because there's an exponent and it is. And so like if we were in a classroom and I was teaching this, like I would do it differently, but there's all these potential rules. Like one is power rule, and that's what this is. It's really u to the minus 6, where u is equal to 5 plus cosecant 4t, like that, okay? And so the derivative of the power rule, like the power rule derivative, right? It's the derivative is -6 u to the minus 7. That's the
Okay.
standard power rule, right? But
Yes.
really, you've been lied to the whole time because there's always this u prime, okay? There's always this u prime. Well, what is u prime? Well, it means it's the derivative of the inside function. The inside function is this 5 plus cosecant 4t.
Okay.
Does that make sense?
Yeah.
Okay. Now we got to go find u prime. Now the problem here is u also has an inside function. This 4t is really v, and you can use any letters you want, but v is kind of the next one that comes up. And v, it's kind of like v is equal to 4t, so there's yet another inside function here. So your derivative u prime is 0 plus the derivative cosecant. Do you remember derivative cosecant?
No, I don't remember.
So that's one you'll want to remember.
Yeah.
Minus cosecant v cotangent v times v prime. Why v prime? Because there's an inside function v.
Okay.
So v prime is 4, like that. And so u prime equals, and this is where you got to decide like how far are you gonna when are you going to back substitute in? So like when you substitute in for u is right up here. U prime is in terms of v, so then you got to put the v and v prime back in. Is that all clear? Like you're replacing for these things?
Yeah.
Okay,
Yeah.
so it's -6u. U is 5 plus cosecant 4t minus 7 power. U prime is minus cosecant v. Now instead of v, I'm going to put the 4t in. Cotangent, instead of v, I'm going to put the 4t in. V prime is 4. And there's your final answer. And just to be clear, these are multiplying. This just happens to be a negative there.
Okay. Okay. I think I got it in. Yeah. Okay.
Okay, we can continue on here.
Mhm.
Right. The whole point of this quiz is to get you to where you can take a derivative of everything, because you're going to use your derivatives for everything
Mhm.
going forward. This one's pretty tough because there's really like two separate things here. Let me kind of
Mhm.
break this in half, break that in half. You got this one, you got this one. And so let's just first look at the 4x e to the minus x. This is a product rule.
Okay.
So you have to know to split it, break it apart. And so your f is 4x and your g is e to the minus x. So your f prime, if you remember product rules, you have to find f prime. Your f prime is 4. Now your g prime, the problem here is that this is really not a u sub, a chain rule problem. Like the derivative of e is itself
Mhm.
times the derivative of the inside function.
Where did the -1 come from?
The derivative of the inside function, which is negative x. So let me back up here. Like if that is unclear, and and it usually is,
Mhm.
what you have to do is rewrite this as g equals e to the u, and u is minus x. So g prime is e to the u times u prime.
Okay.
And then so u prime is -1. So that's where the g prime is. It's e to the u, e to the minus x. U prime is -1. So you can simplify it as minus e to the minus x like that.
Okay. Okay, that makes sense.
So now for just this first one, the derivative is f g prime plus f prime g, or some variation on that. Basically, you take your original function 4x, g prime minus e to the minus x plus f prime, which is 4, and your g, which is e to the minus x, like that. And that's just for this first one. We then have to do the same thing for this 2e to the x squared. We have to, or similar thing.
Okay. Okay, so that's for the first one.
Now for the 2e to the x squared, this is really 2e to the u, and u is x squared. So the idea with chain rule is that you always put it back into something you know how to take the derivative of.
Okay.
So now, because now when you take a derivative, it's 2e to the u times u prime, and now you need your u prime. You know your u is x squared, but what is u prime? U prime is 2x.
Mhm.
Okay, so these chain rules are the most difficult for most students. Typically, these are the ones that they just don't ever get. But the derivative is 2e x squared, u prime is 2x, 4x e to the x squared, like that. All right, so that goes with this previous stuff. So your final answer is all of that stuff
Uh-huh.
plus that's right here. And you just gotta be really careful, like that you're multiplying. I mean, you can actually like pretty this up. Like you could make it minus 4x e to the minus x plus 4 e to the minus x plus 4x e to the x squared. Like that's the same, but you don't have to, I believe, for Pearson. I think it'll take whatever you give it.
And you multiplied them together or you added?
They're added, but the like individual pieces are multiplied,
Okay.
squeezed together, if you will.
You okay. Okay, that's really confusing. Okay.
You know, these don't lend themselves well to learning because they're not sequenced. Like I believe there's kind of a stepping stone when you're learning, and these are kind of big jumps, you know, in terms of the learning process.
Okay. I got it in.
Right. The next one says it's 1 of 25, which suggests it might be from the next one.
Yeah. Yeah, all these have been from the next one. I think I sent them backwards. I'm
Okay.
sorry.
Do you want me to go forwards, like to the end of the email?
No, we can go backwards. It's okay. It doesn't
Okay.
matter.
All right. For this one here, this is really y equals the square root of u, and u equals 9 plus 3x. Okay, so what I'd like you to do here is to try taking the derivative of y prime and then the derivative of u, just to see if there's any questions about this, since you have to do it on your own. Um,
Would y prime be 1/2 u to the 1/2?
Hang on just a second. Be right back.
Sorry.
All right, I'm back. Let me know if you have any questions. I'd take a derivative of this.
Would y prime be 1/2 u to the 1/2?
Minus 1/2.
Yeah, minus 1/2, sorry. And u prime would be 3.
Yes, good.
Okay.
So then your derivative, your answer is 1/2, and instead of u, you put in the 9 plus 3x minus 1/2 times 3.
I think I'm starting to understand.
And the nice thing is you don't have to simplify. You just have to like get it all uh, get it all in there.
So I can put that in the,
Yeah, exactly. So that like what's in the box here is what it is.
okay. So we're separating the y and the u to make it easier.
Yeah. So you're the idea is to always go back to something that you know how to take the derivative of. And you
Mhm.
don't know how to take the derivative of this, but you do know how to take of the derivative of the square root of u.
Yeah. Okay.
So that, I mean, that is the idea. Math is often about taking something and putting it back into something you already know how to do.
Okay.
Okay. So this is a quotient rule problem, an f over a g. So f equals cosecant x, g equals 1 plus cosecant x, like that. Um, will you do the derivative of each of these, please, for us? They're very similar.
Yes. The derivative. The derivative of cosecant is sorry, I'm trying to remember.
Part of me, this is a good thing for you to kind of be like, okay, where is it? How do I find it? What is the derivative?
The derivative of cosecant, if I remember right, is negative cosecant x times cotangent x.
Good. How about the one on the right here?
Would it be 1 plus negative cosecant x cotangent x? Or
The
is it?
derivative of a constant is always 0.
Oh,
So,
yeah.
it'd be
It's just
0 minus cosecant x cotangent x.
okay. Okay.
All right, so now the chain rule derivative, or I'm sorry, the quotient rule derivative is bottom times root of the top minus top times root of the bottom over the bottom squared.
Okay.
Is that okay?
Yes.
All right, so we have the bottom, which is, so that big fraction mark, 1 plus cosecant x times the root of the top, which is minus cosecant x cotangent x minus bottom to top here cosecant x times the root of the bottom, which is minus cosecant x tangent x all over the bottom squared. 1 plus cosecant x squared like that.
Okay.
You could simplify a tiny bit, but I would just enter it this way. I mean, the hardest part is just not entering it wrong, after doing all the work.
Yeah. Sorry, it's a lot to write.
I know. That's
Okay, I think I got it.
I'm gonna be done Okay. Y equals 2 cosecant x. Y equals cotangent. I'm sorry, this is really wrong. Everything I just did. Sorry about that. It's F, and F is 2 cosecant x. G is cotangent x, like that.
So it's always better to separate them.
Well, you have to. I mean, it's a product. You could, for example, put the 2 with the cotangent, but I would just go over those. This is minus 2 cosecant x cotangent x. And then the derivative of cotangent is minus cosecant squared x, like that. That's where you got to know all your derivative rules. You just got to like memorize them. You can forget them after the class is over. That helps, but you got to know them for the class.
Yeah. I just have to practice on the trig stuff because I've never really been good at trig.
You might check and see if you can bring a reference sheet to the exam, and then you just print the derivative rules on the exam, or you stick them in your calculator on a piece of paper inside your calculator. Whatever.
Yeah.
There's lots of options. Let the internet help you figure that one out as well. So the derivative here is f g prime plus f prime g, which means you pair them up diagonally. So for example, it'd be 2 cosecant x minus cosecant squared x plus negative 2 cosecant x cotangent x times cotangent x, like this. Sure.
Okay. Okay.
All right, so we got another question here. So find dy dx for y equals 5 over x plus 8 sine x, like that. And really, this is I don't know, it's a mixture of some rules, but it's if you're just rewriting, it's 5x to the minus 1 plus 8 sine.
Okay.
All right, so now the first one is power rule. So why don't you try that one on your own? See if you can knock that out.
Negative 5x to the negative 2.
Yep. All right, and what's the derivative of sine? Do you remember that one?
Cosine.
So this is plus 8 cosine x, and that's your final answer.
Okay. That one seemed a bit easier. Like I said, the trig ones really confuse me. So
Sure.
Okay.
All right, so we're gonna go back to 17 on the, I don't know which one, just because I don't want to jump
Yeah,
into the harder stuff.
it's on the one, yeah.
Okay, so it's 17. Really, you really just need to rewrite this before you take a derivative. It's x to the 6th over 7 power. So sometimes students aren't sure how to remember that, and this might be a reference thing. There's really a 1 and a 2 there, so this is x to the 1/2 power minus x to the pi. Now the pi is awkward because you're like, why is there a pi? Treat pi as a number. So these are both power rules. So could you give this a try here with a power rule and let me know what you come up with?
Yes. The power rule on x to the 1/2.
No. That's just kind of like how to write the root as an exponent. That's
Oh,
just an example.
oh,
Yeah,
so-
it's this one right here.
okay. Uh, x or 6/7 x to the 1/7 power.
7th x to the minus 1/7 power. Good.
Yeah.
Now the next one's a little bit awkward, but you do it the same way. You bring the exponent down, you subtract 1.
Pi x to pi minus to the pi minus 1 power.
Yep. Looks weird. Probably is weird, but that is
Okay.
all right. Next question here, 18. All right, so they're giving you this function, f of x is 3x squared minus 5x. The derivative of this, could you calculate that for us, please?
Yeah. 6x minus 5.
6x minus 5. And now it says parallel to the line. What's the slope of this line?
Um, wouldn't it just be 7?
Slope is 7. It's important that you're able to identify that. So go ahead and solve this for x, please.
It's 2.
There's 2, so x equals 2. So that's the x value. You get the
Mhm.
y value, you have to put 2 back into this equation for x.
Okay.
Could you do that for us, please?
Yeah. It's 2.
Well, yes, it is. Y equals 2. So that is your ordered pair, 2 comma 2.
Okay.
Okay, next problem here. A lot of, okay, yeah, so this 19 is really similar. So one thing that could help here, when you take your snips, if you want to like make your screen half screen, like on the left side or the right side, that'll kind of squeeze all this together so that it goes onto a second line, which could help. But there's a lot of words here. They're giving you the function, the derivative, the function, the derivative, and they finally get you to this here, right here, which is product rule, f of x times g of x. It's a pure product rule. And we did one like that earlier, was a pure quotient rule.
Mm-hmm.
So the product is straight definition. It's f prime of x, g of x plus f of x, g prime of x, or you can flip the order. So then we're evaluating it at -3. So x equals -3, f prime of -3, g of -3, f of -3, g prime of -3. And you just have to put those values in. So f prime of -3 is 4. Actually, why don't you carry this one out here? Find, get the value for g of -3, f of -3, g prime -3, multiply, and then add, and let me know what you come up with for that.
Okay. Got -8 plus 16, which equals 8.
Let's try it here. So g of -3 is 2. And f of -3 is 4. G prime of -3 is 4. I've got, though, f prime of -3 is -4. Sorry, -4. There it is. There it is. There's your -8 plus 16, which is 8. And that's not the answer. That's just the slope.
Okay.
Okay. It's like, gotta do more. So now we need a point. So what we really need is the x and the y value. So the x is -3, but what's the y value? Well, if you go back to the original, I know it's a little weird, but you're putting -3 in for x. So it's f of -3 times g of -3. So you got to go grab those values again. So f of -3 is 4 and g of -3 is 2.
Yes.
So there's your other point there.
So 8.
8. So now you need to write the equation, and what's nicer is they don't specify it. So you could actually just go y minus y1 equals m x minus x1. So
Okay.
y minus 8 equals 8 for this x minus 3. And I think it will accept this, which is in point slope form,
Okay. Let me type it in.
but I'm not sure because I'll grade these things.
Okay.
Let me really quickly do the last one here, and we'll close out with this one. The first thing is you have to take a derivative of both of these. So the derivative of the first one is a, the
Okay.
second one is 2x minus 23. And then you put 0 in for x. So that cleans this up pretty quickly. You get a 2 times 0 minus 23, which ends up being minus 23. And then you set them equal to each other. So A equals minus 23. So the key here is just remembering to first take a derivative and then to put the number 0 in fraction, whatever like the boundary condition is, the edge condition there,
Mhm.
and
Yeah.
seeing what you
That makes sense.
come up with.
Those look scarier than they actually are.
Yeah. All right, so we're gonna go and stop here for today. Go ahead and
Okay.
stop the recording.